Hello and welcome to this Reigate College video on successive collisions, where we're going to be looking at a ball bouncing on a horizontal surface. So the question we've got here is fairly typical. We've got a ball which is being modelled as a particle dropped from rest from a height of 80 centimetres onto a smooth horizontal plane. So the ball is going to bounce and then bounce and bounce and bounce. The coefficient of friction is 0.5, there's no air resistance, and the ball strikes the plane at right angles. And we've got some questions here. Find the height to which it rebounds after the first bounce, after the second bounce, and then this is the interesting one, the total distance travelled by the ball before it comes to rest. So just to give a little bit more space here, we are going to have a look at what's going on. So what we've got is this. Now, I've drawn the diagram, stretching it out in this direction because the ball is obviously going to bounce up and down in one vertical line. But in order to see what's happening, I've drawn it like this. So let's think about the first drop. What have we got going on here? The initial speed is 0, acceleration is 9.8, the distance travelled is 0.8, and we want to know the velocity just before it hits the ground. So we're going to use v squared equals u squared plus 2as. And when I substitute in, that's going to give me v squared is 2 multiplied by 9.8 multiplied by 0.8. And this gives me v is 3.9597. 9597. So that's the velocity just before it hits the ground. Now you should have in your questions where you've had a ball hitting a wall, you should know that things rebound from hitting a surface with a velocity of e multiplied by the impact velocity. So the rebound velocity will be e times v, which will be, for this question, 0.5 multiplied by this value here, 3.9597, which is equal to 1.979899. So we're going to use the full value in our calculations. So that's the speed that it comes away with here. And we want to find the height after the first bounce. So after the first bounce, what have we got going on? We've got the initial speed now is 1.979899. This value here. The final velocity is 0 because the height after the first bounce is up to here. The acceleration is minus 9.8, and we want to know what s is equal to. Notice that in this part of the question, I've taken upwards as positive. In this part of the question, I've taken down as positive. That's really just because it makes sense to do that. And you can do that, so long as you're very clear on what you're doing. But just watch out for your signs to make sure you get things the right way around. So we're going to use again v squared equals u squared plus 2as. So we've got 0 is 1.979899 squared minus 2 times 9.8 multiplied by, let's call that x. And when I solve that, I get x equals 1/5, which is equal to 0.2 meters. So that's the height after the first bounce. Then it says find the height after the second bounce. So this is the first bounce. We're going to go up and down, and then the second bounce is going to look like this. So for the second bounce, let's think what's going on. The ball sets off here with this velocity. So 1.979899. Now, if you think about it, because of the symmetry of this projectile flight, it's going to come back down here with that velocity there. So for the second bounce, what's going on? So after the second bounce, when it comes up here, the initial velocity is going to be e multiplied by this velocity up here, because that's what it came up from here with. So this is 1.979 going up there. It's going to come down here, minus 1.979. Then we're going to multiply by e again for the next rebound. We're looking for the height, so we need to say b equals 0, a equals minus 9.8, and s is equal to, well, we called that x, maybe we should have called that x1, first height. So let's call this x2, make it make sense. So we're going to use v squared is u squared plus 2as, so 0 is going to be a half multiplied by 1.979899 squared, so that's the e multiplied by this here, minus 2 times 9.8 times x2, and this gives me x2 is 1 over 20, which is 0.05 meters. So that's the height for the second bounce. So this is part B. Part C asks for the total distance travelled before it comes to rest. Now, you're not expected to learn this formula, but you are expected to be aware of what's going on. What we've got here is successive heights will form a geometric sequence. And if we look at this first height, that first height is 0.2. The second height is going to be is 1 over 20, which is a quarter multiplied by that. So the third height will be a quarter multiplied by 1 over 20. So each time it rises to a quarter of the height before. So we could write in here, x3 will be 1/4 times 1 over 20, so that's 1 over 80. But it wants the total distance travelled, so let's think what that's going to be. The total distance travelled is going to be this drop here, which we add on at the end or at the beginning, so let's work that out. So the total is going to be 0.8. This is the first drop here. Then we're going to need, it's going to go up to the first height and down, up to the second height and down, up to the third height and down. So it's going to do 2 times each of these heights. And these heights form a geometric sequence. So this is a geometric sequence. Let's just write this here. This is a geometric sequence. And the first term of this geometric sequence is 1 over 5, or 0.2. The common ratio is a quarter. And we're doing an infinite number of terms because we're going to let it bounce until it stops bouncing altogether. So this is going to be 2 times. Now the sum of a GP to infinity is, so S infinity is A over 1 minus R. So this is going to be A, maybe we'll write it as a decimal, 0.2 over 1 minus 0.25. So that is the geometric sequence for the bouncing. The 0.8 is the first drop. And when we add all of that up, we get 1.33 meters. So that's the total distance travelled by this bouncing ball. The last part of the question says, asks you to criticise the model with respect to the motion of the ball as it continues to bounce. Well, first of all, be very clear what the model is. So it says the ball may be modelled as a particle. Now, a particle has no size. But if you think of a ball, tennis ball, certainly, tennis ball would be maybe not 10 centimeters, maybe about 8 centimeters wide. So in terms of these numbers here that we're getting as our answer of 1.33 meters, that's quite a significant part of the bounce by the time you get down to the lower bounces. So definitely here, the question asks you to criticize. So you would say the size of the ball is not considered. So you're not expected to learn any formula for finding the total distance travelled, but you are expected to be aware that if things bounce repeatedly on a horizontal surface like this, the heights will form a GP, and you're usually led through it in the question to work out what the values for A and R will be.